I chair this institute that is focused on building standards, focused on building ML pledges and stuff that allows machine learning engineers specifically to be able to develop systems that are ethical, responsible, and that are industry ready. I'm also an AI fellow and member of the RSA as well as the EU AI Alliance. I'm an advisor of the Teens in AI initiative, and I'm also a head of solutions engineering at legal tech machine learning company. So I run a department of around 15 machine learning engineers that are building systems that automate language analysis. But as I mentioned, today I'm going to be focusing on the institute as well as on the stuff that we try to bring into the industry. So a couple of things. I'm going to also cover a bit of an overview on the intuition of machine learning. So it's going to be very high level to try to provide a flavor of what it is conceptually. Then the opportunities and risks that could appear in industry. Then a framework for you to be able to implement this when building and designing a system. So this is to what John was discussing. And then some next steps of what the workshop would be. I do have a hard stop at 4, so I'm gonna have to head off, and we're not gonna have time for the workshop, but if you and your friends, are keen to do some cool stuff on ethics, you can try that. Yeah, so let's get started. So the recap on machine learning. So who here has a high level understanding of machine learning? Or concrete understanding? I know Kieran does. Alright, so I think a couple of people that didn't raise their hand, I think, I know that you have also a bit of an understanding. But conceptually, there are two main approaches on AI. There is hard coding the rules, which is actually programmatically defining what you want the program to do, or there is actually building systems that can learn from examples. This is very, very high level, but the AI that most people refer to is the subfield called machine learning, and this is the one that focuses on learning the rules out of data. Instead of you telling a specific program you need to do this and this and that, it would learn that it has to do those specific steps. And in essence, all machine learning is basically trying to take an example and see what the output should be, and then trying to create some logic to be able to start predicting those steps. So let's take a very simple example. If we take the example of squares and triangles, if I give you a shape, I would want the machine to predict whether it's a square or a triangle. So how would we do this with a machine learning system? Well, first we need to create what we call a feature space. In this case, let's imagine a 2D plot where the two features we take is the perimeter and then the area. Based on the shape of the figure that comes in, you would have them scattered across this space. In this way, this is not accurate, but let's imagine that we have in our space the shapes that are over here, right? You see some squares over here and then some triangles over there. What we want to do is we basically want the machine to be able to draw some approximation of a line so that we know that whenever we find that a perimeter is over here and then the area is somewhere here, we can predict with certain accuracy that it's a square, otherwise that it's a triangle. So the machine doesn't know anything about squares or triangles, but it's trying to find some sort of function that allows it to know that over here it's squares, over here it's triangles. And of course it's not always 100% accurate, as there are some outliers over there. But very simply, once we have our function, when we give it a new shape, it would know, okay, this one is actually a triangle. So if we start with a blank brain, we give it some examples. Let's say we give it an example of a square and a triangle. Over here it's going to try to say, oh, well, this is the perfect function, right? And we know that it's not, right? The perfect function is here, but it only knows these two examples. So it's like, okay, I'm going to try to guess it's this one. Then we're going to give it a bit more data. It's going to get a little bit more accurate. We give it more data, and it's starting to get closer and closer to the actual function that is able to divide the actual figures in an optimal way. And once we try to find this function, the way that we do it in this example is we're minimizing a specific function, right? This is how it works. You're trying to minimize the cost. In this case, you want to, or maximize the cost. In this case, we want to maximize the distance across between the line and the shapes, right? So we want to find a line that actually divides those in an optimal way. And once we have it, we can actually use it to predict. This is a very, very simplified approach, but this is what machine learning normally generalizes to. You're always trying to optimize and learn a specific function. It's just that it so happens that, you know, if you want to differentiate much more complex stuff, then you would need different functions that are just not a linear one. So you would want something that is able to, you know, find more complex divisions of the data. You know, the algorithm, the linear algorithm of, you know, the f of x equals mx plus b is the same one that the one you have in your normal perceptron. So one perceptron is basically a line that is able to divide it, right? So this is the exact same perceptron that you find in a neural network, right? So you have here, you know, a little, you know, function where you give the inputs, you multiply it by some, you know, weight, and then you add some bias, and then you get the output, right? And what you're trying to do here is you're just trying to, like, you know, pass all of your, you know, specific features, multiply them in some way, and then know what the output is. Here would be either square or triangle. So in more complex cases, we can take this linear function, which is, you know, through this like perceptron, and then just have much more that gives the actual function more flexibility. So this actually allows you to have more complex divisions of data, and then you add more layers so that you're able to actually have a much more flexibility on the learning of the space itself. And what you end up with this is basically adding more layers, goes into what we normally hear as, you know, deep learning, which is basically the ability to learn from heaps of data and try to approach much more complex problems. I mean, for example, trying to differentiate, you know, cats and dogs based on pictures, you wouldn't really have something as simple as, like, you know, their area and perimeter. You would have all of the pixels of the image, and then you would let the complex function to be able to learn what parameters are able to divide this data, right? So these neural networks or these machine learning models, they basically learn and create some internal representations that, you know, as a human, you wouldn't really care about because it learns it by itself when it's very, very complex models. So that is a very, very high level intuition on top of, like, machine learning itself. Of course, there's much more into it, but, you know, this is just to give you a grasp of what is required from the data that you bring in, and then algorithms learning from that data. This is what they refer to, and that's why, you know, your algorithm will only be as good as the data that you have, right? So if you train it with one specific data set and you try it and you test it with another one, if they're not representative, then you're not going to be able to, you know, really, you know, get good accuracy on that side. So that is a very, very high level overview on machine learning. Does anyone have any specific questions on this point before I jump to the next one? No burning questions. Okay, so if you have any questions down the road, please make sure that you just jump in. So now let's see what, you know, opportunities and risks appear with this technology, because the technology itself has been there for such a long time, but just now with the breakthroughs that are happening, there's a lot that is coming up that we're seeing, and there's a lot of applications in real life scenarios. You know, people using it for real-time optimization, for radical personalization. Whenever you interact with your social network, you're actually interacting with a lot of machine learning models behind it that are using your data to learn what you like to see. They're using it for data analysis, for making marketing decisions. You're using it for anomaly detection, trying to detect fraud. I don't know if you saw, but you know, in China they were using it to try to spot students that are not paying attention in class, right? So what you don't know is that actually we're trying to track, you know, your faces to see who's paying attention. No, I'm joking, we're not doing that. We're also for information retrieval, language analysis, and unstructured data processing. And it's actually affecting all of the sectors that you normally interact with on a day-to-day basis. And this matters because there are also some, you know, technologies that can get out of hand. And, you know, let's have a look at some of these technologies. I'm not sure if you guys have seen some of the things like synthetic phase generation. So this is things like, I'm not sure if this is playing solid this morning. So you have the curse of the demos.
You've already seen this.
You've seen it this morning.
Yeah.
Oh, perfect. Oh, fine. Okay, so I can skip that. But yeah, so synthetic face generation is ultimately something that like it is quite scary because you post things online all the time. So you actually have a large data set that people can actually get access to, and that is something that, like John was saying, we need to be very careful with who actually gets access to this to be able to like learn from that. And let's see if all of my players are gonna. Oh, perfect. So there's also on a voice.
About this new algorithm.
On a voice. Do you guys know who those are?
Yes, it is developed by a startup called Wirepark.
This is huge. They
Yes.
can make us say anything.
What about that one?
Really anything.
The good news is they will offer the technology to anything.
This is huge. How does their technology work?
Hey guys, I think that they use deep learning and artificial neural networks.
Yeah. So I think like ultimately there's that like you can upload a clip of your voice and it can actually replicate your entire voice, and you can add text and it's going to basically speak it on your voice, which is again really scary because imagine combining the voice with a camera, or just using this with a service like Twilio where you can just like programmatically send phone calls to other people, and imagine receiving a call by yourself. That would be very, very weird. Then you have the Google latest release, which is basically the I think videos are not working for some reason.
We watched that.
Oh, perfect, fine. If you guys can let me know which ones you've watched, so I can skip the awkward trying to click on this like not working video player. But yeah, so ultimately there's also a huge use of bots, and there's actually a huge industry for bots that are now opening. So combining all of these technologies does open the questions of where's the limits of things that not only you can innovate for, but also whenever you build, you need to be conscious of what are the perspectives. Have you guys seen how you can actually trick some algorithms as well?
No.
Well, I mean, you probably won't either because you can't really click on this. Let's try to refresh. It's not like demo hasn't gone wrong when somebody refreshes. But yeah, basically what this is a classifier that allows you to use images to say whether it's, for example, in this case, a banana or a toaster. And what you basically are able to do is, because these are mathematical functions that receive a specific input using the pixels, what they do is they try to use an image that doesn't look like really anything, any object, but it represents, in terms of that function, the optimal representation of, say, a toaster, right? So even though it doesn't really look like anything, for the machine learning model, you're basically tricking it by providing the exact inputs so that it actually gives you the output that you desire. And this, for cybersecurity, is very important because you may train some face recognition software that if you're able to understand what is the input that generates a specific person's face, you would be able to actually trick that thing for doing that. And another example, and they call this a hallucination problem for these machine learning systems, and actually they try to do this by adding a very simple change that is not visible for humans, but a machine would be able to pick it up and really getting tricked to think that it's something else that it's not. And you can actually have, for example, self-driving cars, you may have like a stop sign that you pass it through a specific modifier that tells it that it may be an arrow for the car to actually turn right or left or something like that. So I think this is where you start thinking of how can you make sure that you're conscious of the things that can trick your algorithms when deploying something that is actually quite critical. And also with the robots, I mean, some of the videos are working. I mean, hopefully this one actually works. But you guys probably seen this on like your Facebook wall or something, and you see that the advancements are also starting to be used on physical appliances. And also with this, algorithms, you're able to do other things like I think what is this called? I think it's 24 and me, 25 and me, or something like that. Which is basically you send it some sample, and then they are able to tell you your entire ancestry based on your DNA, which is also telling you like whether you're prompt to be addicted to caffeine, or whether you're more likely to go and gamble, And these things, I mean, like, you know, it's really cool, and you're like, oh, okay, I can find out what my ancestry is. But at the same time, what you don't know is that, you know, this company, the co-founder, I think is one of the Google founders' wives. So you know that like all of your DNA data is now stored with Google. And now you're gonna get ads that, you know that you're more likely to, I don't know, like gambling, right? Which is pretty bad. Right, and many people are like, oh yeah, you know, I want to send a sample of my DNA because it's very cool to find out, you know, all of these little things. But you know, you're also not conscious who you're sending your data to. And you know, regulation is also playing catch up. So this is basically just like GDPR asking the questions of, you know, when there's video tools that analyze emotions, when storing your videos on Facebook, for example, when you give consent of people actually storing a video of you, is the question of whether you're also happy for them to store your emotions or your voice or your face, and then be able to recreate your face or your voice or all of these things, right? So it opens more questions based on what is actually capable of happening. And you know, there is a lot of things that are also coming on the top of that, which is, you know, large scale automation of people. That is also coming into discussions and maybe a problem. The new generation of cybersecurity, such as like, you know, being able to find loopholes on these mathematical functions, improvement in defense and attack systems, which, you know, also opens up on discussions on when this is okay. Algorithmic bias is basically what John was talking about. When you train a machine learning model, you may be training it, for example, on samples of English. Right, and English text may not be as representative as say, for example, Spanish text or other different types. And then there are disasters that could happen because of lack of regularization or dangers of staying behind between one country versus the other. So, you know, there is a lot of opportunity as well, but it is the question of how can you guys make sure that, and I think that is the most important question, is knowing that all of this is in the potential future. How are you guys can equip yourselves to be able to deal with this and to be able to contribute and make a positive impact? Because you see all of these examples and then you think, well, how can I make a difference? And I think this is where the ethics by design comes in, and this is basically a framework for you to think about how can you actually take a step and really think through how can you develop things that are for the better of like people, humanity, your community, etc. And there's a question as well, it's like, you know, what even are ethics and why are they important? So I guess, I mean, can somebody give me a high level guess of what is ethics? This very, very ambiguous concept. I mean, does anyone want to give it a try? Well, what is ethics?
A set of moral rules, basically.
Yeah.
Something like that.
Pretty much, yeah. So, you know, very, very, you know, high level is basically moral principles that govern your behavior, or the way that, you know, you conduct in a specific activity. It's basically like, you know, in many ways could be how to live a good life, our rights and responsibilities, the language of right and wrong, the decisions of what is good and what is bad. Even the actual meaning of good is already quite, you know, philosophically heavy. And you know, we actually apply them on a day-to-day basis. Even if you don't know the actual exact meaning, you know, I mean, can I get a show of hands? Who here thinks that cheating in a test is good? I mean, right there, well, I mean, besides Kieran, besides that, but you know, it's also asking the question of like, you know, in what context, right? Is it like, you know, in this context when actually cheating in a test, you know, is required? Well, I mean, I'm not saying that, you know, there's probably like a very small subset where that could be the case. But yeah, it's basically like, you know, should you stick up for others? You know, maybe the answer is yes, but the situation may actually change the answer. Is there a situation where lying isn't bad? You know, it's like, should you tell someone, should you tell on someone to help them? You know, it's like, you know, when is things right or wrong depends on the situation, as well as you know, on the culture and on what people think is good and bad. So it's a very, very philosophically heavy, you know, point. You know, and when it comes to AI, it is a wild, wild west, because, you know, it's basically a very, very new field. Even though it's been there for a long time, like a lot of discussions are arising where people have never really thought about that. And they're really hard answers. It's not just something that you can say. But from our perspective, the way that we think about it, the main times where stuff goes wrong, in like examples that we've seen with Facebook and other samples, like it breaks down mainly on two parts. On individual basis, there are times where somebody may be unconscious of the implications, right? You just don't know what the technology can do, so you end up having an accident and something bad happens. Or maybe that person is plainly unethical, right? Like they're conscious and they know they're doing something bad. Or they're plainly unconscious and unethical, which I don't think it's as common. But yeah, so or ultimately you want to make sure that you're conscious, you're aware of what's going on, and you also have the right ethical framework or the right way of approaching problems, which again is quite charged. There is this problem, a dilemma in autonomous systems, that is talked in very different ways, normally as a trolley problem, which is basically if you find these two people that are driving around and then a set of boxes from the car in front, falls into them, what is the right decision for an autonomous car? Should it hit like the car in front? Should it try to dodge it and go to the left and affect the car on the left? Should it try to go to the right and then affect the motorbike? There's an algorithm driving this car, right? And the decision of actually going and doing an action and having an effect, it could be seen as an intended effect. So it gets the programmer into the decision of, well, if it is in this state and it does something, what should I make it do? Or if it does something that is not correct, whose fault is it? Is it the developer's fault? Is it the tester's fault? So it does open a lot of really, really hard questions and dilemmas that are really hard to really address it. But instead of going into this philosophical discussion of what is right and what is wrong and what is the ethical framework, what I normally try to do is I try to focus on a much higher level perspective. And one of the questions that were raised is, how do you make sure this applies on a cultural by cultural basis? And I think for me is, how can you make sure that you get the basics on a blanket set of approach that gives you the tool. And this is basically the human-centered / industry-ready design set of phases that is basically outlined in certain extent in that report, but this is more focused on an actual engineering perspective. And yeah, how can we address this? People may think that programming looks like this. It does sometimes in your mind, maybe, but in reality, it's much more boring and structured. For us, the way that we try to address it is in 4 phases within the institute. We want to first start with ethics by pledge. So we put together a machine learning pledge, which engineers or people that are involved in AI can actually go online and just sign the pledge. The next step is ethics by process, which is in companies or basically in groups. You can have a process that ensures that you have ethics by process. Then by certification and standardization. This is with things like the IEEE standard. And then in the long term is by regulation, right? This is very, very long term. So we start with phase 1, which is basically using the machine learning pledge, which is basically 8 commitments that allow you to really just say, as an engineer, I commit for this 8 set of points that allow me to at least explicitly state that I have a right approach into be able to understand what I should be looking at, right? It's like, what can I focus in as a programmer, as a designer in AI systems, so that I can at least be conscious of the things that I should be trying to tackle. And I want to put the 8 different commitments in a case study specifically on an automated insurance calculator, right? So basically it's going to be a machine learning system that based on your data, it's going to predict what your insurance will be, right? So I'm going to cover for each of these commitments, what is a bad way of approaching it and then a better way of approaching it. So let's imagine in terms of the augmentation, whenever you have a machine learning system, you can have an end-to-end system that is able to actually run a prediction, right? But if you have the system running the prediction by itself without human intervention, then you're going to get that, right? Like you're not going to be able to get a system that just goes and knows everything that a human does, right? So what is bad is to actually doing a prediction without checking or having a human intervention. And what is better is to make sure that you have a human extending their capabilities as opposed to just automating it. You're augmenting the human's capabilities. The second one is the awareness of bias in data and models themselves, right? So something that would be bad is you train in all data or you train on not sufficient data. Because ultimately you may have data that itself is biased. Maybe you collected it from a subset that it was only from a specific area of your city. Or maybe you collected only a sample that is actually not going to reflect well. So this may lead into discrimination on specific either ethnicities or specific gender. This could be even leading into potential bad implications when deploying it into live production. So instead, you need to make sure that you develop infrastructure that allows you to understand your bias and your variance to be able to avoid this discrimination on your data itself. You also need to be aware of the job displacement implications. Ultimately, there is an automation that this technology can bring to the table. You can actually bring in and make humans more efficient, which allows you to make sure that for a specific manual job, you need less people, right? But you don't want to just come in and blindly just automate everything as it comes, because ultimately you're also leaving a hole that requires for oversight and understanding of what these new roles are going to be required. So you need to make sure that there's a transition when building the systems, that you know who you affect and how you can address it, so that the people that are affected can also move into new potential opportunities. And we've seen this within the legal sector, for example. Building systems that make people more efficient actually make, of course, the need for jobs in that specific area more reduced, but ultimately, because the cost of that service decreases, the demand actually increases. So people want it more because the cost would decrease. Then another one is the actual practical understanding of your accuracy, right? So you are trying to optimize a machine learning model to become better at a specific task, right? In order for you to become better at a specific task, understanding the accuracy is actually very important, right? You need to understand how a human would judge a good result versus a bad result. And this is actually sometimes very hard, because a human judging something, especially if it's an image, it could be something that actually could be deceiving on first sight. The next one is awareness and plan for having transparency, right? Whenever you train a machine learning model on data, you need to be aware that you need to explain in a certain way why it made a specific decision, especially when you find yourself with a system in production that may have potential implications or negative implications. You need to be able to go back and say okay, well, this is why it potentially did this. It doesn't have to be specifically on the mathematical representation. It could be just on the data that you use. But you need to be aware that explainability is very important. Another one is backwards compatibility and versioning. So you need to make sure that you assume that all of the models that you build, they actually can be stored in ways that can be retrieved, that can be versioned, that can be explored, that can be extended. Because a lot of the times you find yourself, iterating into this development of machine learning, and you end up with a mess of models over here, data over there. You need to make sure that you are able to keep track of all of the stuff that you develop, an ability to show how it has progressed in case that somebody did a modification or something like that. Then transparency on data and metadata collection. So this is something that is important, because if you just assume that people understand what data you're using, then people may actually say, okay, you can use it at the beginning, but when they realize what actually the data is teaching the machines and what the machines are able to extract from you, then they may actually think it's an unfair or even unethical use of their data. So you need to really understand that you're talking to people that may not be technical and maybe not be tech savvy at all. So you need to really explain to them in their language how you can actually use their data. In case, for example, of this insurance calculator, you may not be telling them that you're actually using a lot of their very, very personal data to infer a lot of the things that should be much more personal, like addictions or things like that. And then the last one is identifying cybersecurity threats. So this is the way that hackers get to your network. We all know that this is the practice that people use. But yeah, it's something like that. People are still trying to understand like what really this field is about, because using new technology, it actually opens up for new potential risks that you need to start becoming aware of and put processes behind it, because otherwise you're just gonna try to approach a new technology blindly, and it may have detrimental effects on it. And yeah, so those are basically 8 commitments that they're a bit more specific to machine learning engineers that are developing systems that act autonomously and learn from data. But if you're a designer, or if you're whether a UX or UI designer, whether you are a product manager, or whether you aspire for policy, all of these things are things that one level or another you're going to be interacting with. So you do need to understand some of the implications of all of these points, because ultimately you will be making one decision or another, or at least interacting with it. So it's important to know how they affect you personally. And in terms of next steps, so this would be where you would apply it into your day-to-day life. We would actually run a workshop, but we don't really have time for the workshop. But if you do still want to run it at some other point, what I would recommend is to try to pick up one of these use cases, things like self-driving cars, emotion detection ads, automatic court prediction, smart classrooms, cameras using crime detection, or smart robot waiters, or whatever you can think of, and then choose one of the pledges and try to analyze what would be a bad way of approaching it and what would be a better one, given the implications of that. And with that said, today we covered the AI ML recap, opportunities and risks, ethics by design, next steps. You can find the code for this presentation, the actual slides and the code on both of this GitHub repos. But if you go to teensinai.ethical.institute, you'll find the live presentation so that you can just have access to it, go through all the links. Hopefully the videos will work. And with that said, that is it. Thank you very much, guys. Let's see.